Yeah, so that was the base cases. Now we will look at the optimal substructure, which, like I said, is the all encompassing formula which tells you how to use the smaller solutions to reach the bigger solution. So you assume your base cases are sorted and this much of a table is ready with you. Now you just need to fill in the remaining boxes. So at every step, what is happening is a new denomination is being introduced to us. So using 1 rupee coins alone, how do I make each of these amounts of money? I know, I just figured out somehow. Now someone's introducing a new denomination called rupees 2 to my currency system. Now I have to at every step make a choice of, do I want to include this new coin or not in making this amount of money. So I know very well how to make 10 rupees just using 1 rupee coins. Now someone comes and tells me this is a new set of coins called 2 rupees. You are allowed to use the existing 1 rupees as well as these 2 rupees. Now I have to choose. I have two options. Either just using my existing 1 rupees, I can make up 10 rupees and I can pay it to you. Or I can take some of these 2 rupees also in combination with the 1 rupees. And then I can try to make up a sum of rupees 10 and I can pay it to you. Now because this is a minimization problem, I have to consider both alternatives. I have to see which one gives me fewer coins and I have to choose that alternative. So at every step, we either choose to pick one coin of that denomination or to not pick that coin. So if we choose to pick that coin, our exchange value decreases by as many units as the value of the coin, and the total number of coins increases by 1. So I'll explain that. So let's say, what do I take? Okay, I want to make 10 rupees. I am allowed to use 1 rupee coins only, then the answer is 10 coins. Now someone introduces this new currency called 2 rupees to me, and they're saying, again, you have 1 rupees and you now also have 2 rupees. I want you to pay me 10 rupees. So I can either choose to pick one 2 rupee coin. So if I pick a 2 rupee coin, then my number of coins now is 1. I have picked one coin and the problem reduces to coin change problem for 8 rupees. Right. So what happens is, when I pick say a coin of X rupees, that is one coin I have picked, so the number of coins becomes a 1, or it gets incremented by a 1, and my problem now reduces to a smaller version of the same problem, which is the total E minus X rupees. I have to again make change. Or if I choose not to pick a coin, then my exchange value remains the same, but the denomination 2 or whatever I'm choosing not to pick is not allowed to me anymore. So coming back to our 1 and 2 rupees exchange value 10 rupee example, if I pick that 2 rupee coin, now I have one coin already picked in my wallet, and now I have to make 8 rupees using 1 or 2 rupee coins. If I choose not to pick that 2 rupee coin, then it means my exchange value is still 10 rupees because I have not picked any coin at all. The number of coins I have picked is still 0. There has been no increment. But this 2 rupee coin, I am not allowed to use it ever again. So I have to finish only using 1 rupee. Why am I not allowed to use it ever again? Because if you wanted to pick it, you should have picked it in the first iteration itself. It makes no sense to say, right now I will not pick it, but later on I will pick it. That's not how change works, right? So you either want this coin or you don't want it. So that's the logic. So I'll explain it again. So like I said, when you come to the ith row and jth column, it means you want to make j rupees using any of the denominations up to I. So let's say my rows 0, 1 and 2 are also filled. Assume the second row is filled. Somehow we got the numbers through some magic, they are filled. It means I know to make any sum of money ranging from 1 rupee to 10 rupees using just 1 and 2 rupee coins. Now you're coming and introducing a new denomination called 4 rupees to my currency system, and you're telling me you can use this also if you want to. So I will either choose to use one 4 rupee coin or to not use. So and let's say my target value is still 10 rupees. So if I choose to use that 4 rupee coin, then I have picked one coin, so the number of coins I have picked becomes 1. and the target value now is 6 rupees, because out of 10 rupees I've already accounted for 4. So now I have to make up 6 rupees again using the denomination 0, 1, 2, 4. So it reduces to a smaller sized problem of the same type. Again, within that 6 rupees, I can choose to pick another 4 or to not pick, and so on. It recursively continues. Or if I do not pick that 4 rupees, the number of coins I picked is a 0. My exchange value still remains 10 because I have not picked anything, and the only denominations allowed to me are 1 and 2 rupees. So whatever is the fewest number of coins I need, using 1 and 2 alone to make 10 rupees, that only becomes my solution. So you see that at each stage we have two options: either pick the coin and reduce it to a smaller version with all the denominations so far, or you choose not to pick the coin and reduce it to the same exchange value but only up to the previous denomination. So that is exactly what, so those two alternatives, and because this is a minimization problem, you will choose the minimum of those two alternatives at every step. That is exactly what this highlighted sentence tells us. CCP of I of j, so I am choosing to call this table CCP because coin change problem, obviously. I, j, the indices, and you know very well by now what they mean. Minimum of two quantities. What are they? 1 plus CCP of I of e minus I. So when that coin of I rupees is picked, it becomes one coin chosen plus CCP of all the denominations up to I, exchange value minus I rupees. So I picked that 4 rupee coin, so my exchange value goes from 10 to 6, 10 minus 4, which is why CCP of I of e minus I. And that this one accounts for that one coin which I just picked. Or if that coin is not picked, CCP of I minus 1 of E. So there is no 1 here because nothing was picked. The exchange value remains the same again because nothing was picked. And I minus 1 because this particular row, because I rejected the 4 rupee coin, this set of denominations, this avenue is closed for me. I now have to make do with whatever I had previously, 1 and 2, up to 2 rupees. So I minus 1, the previous row. That is what the formula for filling in any cell is. So this is what I mean by an optimal substructure. It tells you, using the previous values, using another value in the same row or a different row, different column, whatever, some of the previously filled values, you compare them, you do some operations, and then you are able to reach the value for the current cell. That is what we mean by optimal substructure in any dynamic programming question. So I will quickly give you the final optimal substructure, which includes all your base cases and everything. So CCP of I of j will be a 0 if your exchange value is 0, or if you are not given any denominations, which makes perfect sense. CCP of I minus 1 of j if I greater than j. So if your denomination is greater than your exchange value, you are not going to be using that denomination. So you just go to the previous denomination of the same exchange value, whatever that number was, you will copy paste. Otherwise, if I less than equal to j, if your newly introduced denomination is still less than the target value, maybe we can use it, maybe we will not use it. So there is this choice. If you pick the coin, it becomes 1 plus CCP, all denominations so far, exchange value minus whatever you picked. If you do not pick it, CCP up to the previous denomination, same exchange value. So you will choose the minimum of these two because it is a minimization problem, and you will fill in the table at every step. We proceed from left to right, top to bottom, as always. So that is the optimal substructure for the coin change problem.